My name's Mark Pearson, and I am a Chief Technologist of our data center networking with Hewlett-Packard. And I'm here today to talk to you about some what we consider game-changing technology for enabling cloud computing. And it's technology that we call virtual application networks, and it's based on the principles of software-defined networking. Okay, cloud computing is a large disruption in our world today. However, with disruption comes much opportunity, and it's with this opportunity that we see several trends that now allow us to offer networking solutions that better match the application deployments. So workloads in the data center are now going to be virtualized. By the end of this year, we can expect at least 50% of application workloads to be virtualized, and that number will continue to increase. We will see within another 2 years at least 60–70% of workloads in a virtualized environment. So virtualization is clearly key. Another trend is the use of mobile and mobile computing, and that's also driving a lot of this change in cloud computing. So what does this mean to the network and deployment of applications? The customer of cloud computing requires speed and agility to deploy applications. And today, unfortunately, it takes a long time to deploy a new application. It can take as long as 3 months, and a lot of this delay is due to deployment of the network. And so this is clearly unacceptable to the cloud computing. So let's take a focused look at what it takes to deploy a new application. The server administrator has many tools that are based on policy and rapid deployment of server applications. But when you look at the network administrator, their ideas are low level. Look at the types of questions they have to ask. They're very low level attributes about the network interfaces. And today, they often translate these into CLI commands and very primitive tools. So this leads to a very slow deployment of the network application. Take an example. Suppose you had a data center with 500 servers. And if each of those servers is carrying 20 virtualized workloads, we are now up to 10,000 virtual workloads that are running. And if each of those virtual workloads has a network interface with 5 attributes, we are now up to 50,000 network attributes. And if each of those attributes requires, say, 5 lines of command line interfaces, we are now up to 250,000 lines of configuration to manage the network. Okay, this is what is very slow and very tedious. So this is clearly unacceptable, and this is something we need to solve. The other issue with legacy networks today is they tend to be application indifferent. They're not application aware. This is difficult to meet the individual SLAs, and in the cloud computing environment where change is frequent, the workloads differ, the legacy network can't handle that type of application. The networks also tend to be very rigid and static. They're based on single tenancy, single applications, or only few types of SLAs for single classes of service. And finally, as I mentioned, these networks are deployed with manual management techniques, CLI, scripting of the CLI. Okay, so this brings us to what is the network vision. And the point here is that we need to now stop focusing on the manual configuration of the infrastructure. The infrastructure now needs to become automated. And instead, we need to now focus on delivering services. We need to now introduce a layer in the network that concentrates on the service delivery, the matching of those services to applications, and the applications to users. So we are introducing a concept we call the virtual application network. And this concept is based on the principles of software-defined networking, in which we have a control plane that hides the infrastructure and instead concentrates on the delivery of these services. Now, one of these services is virtualization. Last week, I was at the conference for the Open Network Symposium, and this is the conference for the OpenFlow standards. And the question was asked to many panelists is, what is the killer application for cloud computing? And clearly, the answer was virtualization. And so here, not only are we trying to provide virtualization, but we're trying to match it to application awareness and matching it to the configuration automation systems for cloud computing. Okay, so how do we build this? Well, we start with an architecture that's end-to-end, that encompasses campus, branch, and data center. And across that end-to-end should be a management infrastructure. And this is what we call the flex network architecture. So we want to build on this type of architecture. Okay, so if we take this starting architecture of the flex network, and now what we want to do is introduce virtualization, and virtualization with programmability. And we do this by introducing the end-to-end control plane. The end-to-end control plane being separate from the infrastructure, not necessarily embedded with every device, but rather a central control plane. Now, have we done this before? And the answer is yes. A couple of examples are where we have virtualized chassis with the technology we have. It's called Intelligent Resilient Framework, or IRF, in which we can create a single control plane that manages multiple boxes or multiple pieces of infrastructure as if they are one device. There's one configuration file. There's one interface. It's a central control plane. So we can leverage that technology to create a larger end-to-end control plane for the Flex network. Another example is with wireless and AP management. So it's very common now that access points are managed through a centralized control plane called the wireless controller. So between these two technologies, we can leverage that experience and now create the central control plane that manages a complete cloud computing infrastructure. Okay, there are some other functions that are required beyond just the virtualization. And an important one that we believe in is in application characterization. And so by introducing the concept of a template to describe an application instance, we can now use policy-based management to match the network requirements to application requirements. Now, these network templates need not be one for every application. They can instead be a choice that the server administrator uses to match against his deployment of the application. So, for example, the server administrator may have up to 200 applications. And instead of picking policy on a one-by-one basis and customizing them, they can choose from a set of network templates that represent capabilities of the network. And so this creates a fast automation between systems administration and network administration. Okay, the next step then is to take this network template and allow the server administrator who's matched that template to his application to create a concept of a virtual network. So to the systems administrator, the virtual network represents a logical grouping of his servers and his applications. At that point, the server administrator is now ready to start the network. And he simply says start, and to the network now takes on this role of orchestration. And it's this job of orchestration through this end-to-end control plane that automates all of the infrastructure and hides all of that device-by-device configuration. This is the beginning of the end of CLI. That now we go to an automated system managing the infrastructure, and instead focus on the delivery of the service, and in our case, a virtual application network. So if we look at our model of the end-to-end architecture called the Flex network, we can now start to deliver these templates as a layer above the virtualization control plane. And as we deliver these applications, we go through these functionalities of characterization, virtualization of the network, and finally the cloud, the automatic orchestration of the automation of the devices. So even though we consider this game-changing, it's also familiar and comfortable technology because it's very analogous to what the hypervisor did to the server. The hypervisor created virtualization of the server. It created policy tools to rapidly deploy virtual machines. And so now we take the same concept and apply it to the network. In effect, we get the network hypervisor. So the network hypervisor having these attributes of virtualization, application characterization, and orchestration of the actual physical infrastructure, just as the hypervisor did for the server. So much of this technology can be leveraged on top of OpenFlow. OpenFlow is a complementary technology to delivering the virtual application network. So HP has actually been very involved with OpenFlow from the very early inception. It started with collaboration at Stanford University with a project called Ethane. And HP and our research laboratories called HP Labs was a key participant in this project. And from there, we instantly created a demonstration firmware for our switches that was available with the OpenFlow 1.0 standard. And we made this available to researchers from an early on, and it became deployed throughout universities and research institutions. And then after this, we started to see rapid deployment of acceptance of this technology. And so we went from 10 to 20 to over 60 deployments of the OpenFlow-based firmware. And some of these installations are not only research or academic, but they're actually used in production and mission-critical environments. And then finally, last year, the standards organization for OpenFlow was created called the Open Networking Foundation, and HP was one of the initiating members of this. And in fact, it is a member of HP that runs the standardization of the protocol for OpenFlow called the Extensibility Workgroup. So what does all this mean, OpenFlow? So it does a couple of things to the virtual application network. Number one, it creates an open standard for device programmability. And it's through that open standard that helps the orchestration aspects of automating configuration. And so what we've done is actually, we have released up to 16 models now with OpenFlow capability, and that will continue to grow throughout the portfolio. Okay, so let's put this to use. How does it work in a use case? So we talked about orchestration, we talked about virtualization, and we talked about characterization, virtualization, and orchestration. So let's start with characterization. So what happens here is the network administrator and systems administrator, they work together to develop these templates. And these templates represent the class of needs that the system administrator will need. These templates are stored within the network administration system, the end-to-end control plane. Those templates are then published to a systems administrator policy tool in which the system administrator now sees these templates when designing his applications. At that point, the systems administrator has defined the virtual network with the applications, and when he's ready to deploy, he says start. This triggers now the orchestration aspects of the central control plane, and which handles the complete device configuration throughout the network. So this takes an important aspect. I talked about network delivery of cloud applications taking weeks or months, and this reduces that from weeks down to minutes, literally 5 minutes of time to configure the network. So another thing to consider here is how do we ensure correctness and testability of the network. Early on, I discussed how we may have to configure 250,000 network attributes. And those, if you consider that maybe 1 in 1,000 of those attributes can be an error, The hard problem for the network administrator is how to find that error. And with a system like this, we can now automate that configuration, and we can start to introduce tools that verify the network, that ensure its state consistency with the policy. So a little more on how we actually deliver this. So we have a tool that we call IMC as a network end-to-end control plane. And so we introduce a virtual application network policy engine and an virtual application network designer. And it's through that designer that we develop these network templates. And so, and then in the case with a server administrative tool such as a hypervisor manager, we have a plugin that allows that publishing of templates between the network administration and the server administration. From there, the virtual application network policy engine will deploy or orchestrate the network for all of the configuration. And so this is where we see an actual switch with the virtual application network policy configuration. Okay, so we believe virtual application networks will deliver the cloud. It introduces an end-to-end concept called the control plane, which is a foundation of software-defined networks. It's a control plane that is separate from the integrated data plane, and thus provides an end-to-end programmable multi-tenant environment. This allows us to, number one, to tune the network to application requirements. And then we virtualize the network and orchestrate it into the actual infrastructure. It enables the IT manager to use policies instead of CLI or scripts. And as I said, this is now the beginning of the end of the CLI. We have a single pane of glass to manage the network and orchestrate it with the system's administrative tools. So we believe this is the new model for networking in the cloud computing era. It ensures choice, it ensures flexibility through the use of programmability, APIs, open standards like OpenFlow, and it's built on an architecture that's end-to-end that we call the Flex Network Architecture, which we believe is the blueprint for developing network applications for the cloud. Okay, and thank you very much.